Alrighty, number 7. From the similar triangles in the diagram, write a proportion using the ratio. Alright, let's think about what their ratio is. It's Wx over Wv. So let's look at that. That's Wx over Wv. Now, in this triangle, that's the short side over the long side. So, let's just look at the other triangles and put the same ratio up there, short side over long side. So we can have Vx over Vy. So Vx right here of this triangle, short side over the long side. And then we can have Wv over Wy. Again, let's look at it. Wv right here over Wy. So the short side over the long side of this big triangle. So right here is your answers. Okay, let's see if we're recording. We are. Okay. Geometric mean. We have to remember, all we have to remember in a geometric mean is we have a over x is equal to x over b. And we're simply going to cross multiply that to get our geometric means. So this would give me a times b, ab equals x squared. So we're just going to utilize these numbers and do that. We have 6 over x equals x over 10. Well, I simply cross multiply. I get 60 equals x squared. I get rid of the x squared. I just take the square root of both sides. That'll give me x equals the square root of 60. We're not going to use our calculator. We're going to break this down as 15 times 4. I'm looking for a perfect square, and 4 is a perfect square. So now my final answer, I pull that 4 out because the square root of 4 is 2. I'm left with the square root of 15. So this one is x equals 2 times the square root of 15. Okay, geometric means again. So in this one, what do we have? Remember, we just want to think about a over x equals x over b. So 275 over x equals x over 11. And if I multiply, I have to get my calculator out. So 275 times 11 equals 3025, which is equal to, right here, x times x, x squared. So we just can do some work on that. This, we want to get the square root of both sides. That'll give me x equals, well, let's see. That happened to be a perfect square. So x equals 55. I just took the square root of 3025, and it was a perfect square. If it wasn't a perfect square, I would have left what was left under the radical. I didn't want to come up with like 53.789 or whatever. I would have left it under the radical sign. So that was number 9. Okay, find the values of a and b. So we're going to have to think back to our corollaries. It said S1 over A equals A over S2. S1 and S2 stands for side. So that's when we're using this altitude. So we're just going to set this up as a over 6 equals 6 over 8. Here's our side 1 and our side 2. And we're sharing this altitude right here. So I cross multiply these and I get 8a equals 36. Divide both sides by 8. And I get a up here, I'll put it up here, a equals 4.5. Okay, so that gives us a. So now we know that this side here is 12 or 4.5 plus 8. So now we've got this, we can set up this proportion 12.5 is to b as b, another corollary here, is to 4.5. So notice that we're using this side combined total of 12.5 and our shorter side, and then that's going to give us our b. So 12.5 times 4.5 is 12.5 times 4. That's not right. 12.5 times 4.5 equals. So when we cross multiply, it gives me 56.25 equals b squared. And if I take the square root of both sides, get rid of this b squared, square root of 56.25 is 7.5 equals b. So b equals 7.5. You may have to pause that, back it up, and take a look at it again, but there you go.